It will not affect your grade. It won't go in the grade book at all, fellas, until you have a 20 out of 20. So I just was grading general chemistry, took their first element quiz yesterday. So far the highest score is a 14 out of 20. So I don't think that they took it very seriously. I don't think they thought it would be hard, but hopefully you guys can do a little bit better than that. Yes, Elliot?
Are we going to learn to do the Lewis doctrine?
We're learning that today. Okay, so this is the plan for today. We are going to learn how to do Lewis dot structures. We are going to learn how to get ourselves ready for chemistry lab, and I'm going to give you your lab notebooks because we're going to do a lab in class on Friday. It's not a pants lab, so you do not, and it's not a goggle lab either. So you do not need to have different clothes for class that day. And then the last order of business, with the last bit of time, you'll take your element quiz. It's 20 questions. If you're spending more than 2 minutes on a question, if you're spending more than half a minute on a question, you're spending too much. Because you probably just don't know it. And that's okay, because you'll take it until it works out. All right, so I want to go back and review electron configurations just a little bit. Oh, hang on. All right, so I want you to take a look in your notes at what you have written for electron configurations, because in order to do some of your homework problems, you need to know how to write electron configurations for that F block that's in the bottom. So before we do that, let's do an example of something that's easier. I'm going to choose germanium. Okay, so remember how to do this. You are going to, when you find a random element, you have to start at the beginning. So there are two different ways. You can either do the full or the condensed. Let's do a full electron configuration for germanium to help us remember how to do this. Let me grab my periodic table picture. One moment. So always when you have to start a brand new electron configuration and you have to write the full thing, you're starting at element 1 and you have to go all the way through your periodic table to the place that you're looking for, which for us right now is germanium. So now you should have written in your notes that these 2 columns is the S, these 6 is the P, D, and F, right? I would maybe find a way to write that on my periodic table that was clear to me. However you want to do that is fine for you. Or I would draw this little periodic table on the note card that I was planning to use on my test. Okay, so this is our goal. This is our starting point. We have to go through every single element of the periodic table one by one in order to write electron configuration. All right. So remember that the first row has a different configuration, like that's the exception to the rule. So the first row is always 1s2. And that'll get us from hydrogen through helium. Now we're at helium, so we should go down to the next row, and we're at lithium. Remember, we're going to write the number of the row first, the quantum number. We're going to write the letter for the orbital, and it's S. How do I know that? Because I'm going through this little bit here right now. And how many columns of this S did I go through? 2. 2s2. All right, that means I'm ending with beryllium, but that's not my goal, so I have to keep going. What's the row number here for boron? 2. Because really, helium is that 1. All right, so then 2, what is the orbital letter? And how many columns do you have to go through? All 6 of them. Because germanium is way down here, and we're up here at boron. So if we go all the way through here, we're still not at our goal. All right, so then after neon, we're going to go down to sodium. What's the row number for sodium? 3, right? We're back in the S block, and we have to travel through 2 columns. That'll bring us to magnesium. Oh. But that's still not our goal. So what's the number of row for aluminum? It's still 3, because the P and the S are the same. How many columns do we need to go through? Again, all of them, yes, so 6. Still not our goal. So now we're here at argon, we need to keep going. Potassium will be the next one. What's the row number for potassium?
4.
Good. Oh, thank you. That's so lovely. What is your letter? S. And how many columns do you have to go through?
2.
Praise be Jesus. All right, now you're here. What's the row number for scandium?
4.
3.
3. Oh, 3.
I know, right? Because remember, we have those have to a 1 smaller than the S. All right, what's your letter for scandium's little section? D. And then how many columns of D do we have to go through?
10.
Correct. All right, so that puts us here at zinc. Now we're not done though, because here finally though is our end point. What's the row number for gallium?
4.
That's back to 4. You're right, S's and P's are the same number. But now how many columns of P do we have to go through? Correct. So that's your full electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. How are we feeling? Thumbs up, thumbs down, thumbs medium?
I just don't know why.
That's a great question. That's a great question. Why do we need to know how this works? Because it's one of the things I have to teach you. It's honestly, I feel like we learned about it today and then we'll never use it again. And so I actually feel like it's my least favorite thing to teach. Like it's fun, it's easy, but I don't see the point of it. Elliot, did you have a question? Yes. All right, so now let's pick a different one and let's do the condensed electron configuration. Let's choose palladium. Palladium is PD. So when you're choosing the condensed, remember that you can just choose the noble gas that comes before it. So not the one that's closest, but the one before. So in that case, for palladium, it would be krypton. So Kr in the square brackets. And then you can start after Kr the way that we were just doing before. You just don't have to write all of the previous stuff. So then we're at rubidium. What's rubidium's number, or like row number?
3rd.
We're here.
5.
5, yep. So that's 5s2. Because it's the noble gas that comes before. Not the one that's closest, but the one before it. You always want to choose somebody in this last row, but like if it's the one that's after, that doesn't make sense. Okay, so we've gotten to the 5s2. Now we're at yttrium. What is yttrium's row number? You should have it written on your periodic table. It's 4. That's the D block. And now it looks to me that palladium is in the D, so I'm going to have to count how many Ds we go through. 1, 2, 3, 4, 5, 6, 7. It's the 8th D. All right. Thanks, gentlemen. I knew when the letter D came out of my mouth that it was going to be a problem. But that's all right. Any questions about that? Does that make sense? Okay, if you're still feeling confused, that's okay. Come see me in jet block.
What's the technique called?
The condensed.
Okay.
Thank you for asking that. All right, so now I just want to show you what is going to happen if you have to write an electron configuration for somebody in the F section. So let's choose erbium, which is element 68. Erbium is ER. All right, let's do a condensed for erbium. Now remember, when you are taking your element quiz, the symbols for the elements are case sensitive. So even though I like to write all of my R's as capital, even if they're like I don't mean them to be capital, it's not okay for me to write this. Or even if I have barium and I do this, that's not okay. That's not what we mean. We actually want it to be the lowercase letter. So when you get to element quiz time, if there is a second letter, it needs to not be capital. All right, so back to erbium. I need to find his previous noble gas. This is a little bit harder because spatially it looks weird. So I'm going to look at the number. If my element's number is 68, which one of these noble gases will be the one right before it? Should I choose 86 or 54? 54. It has to be less than 68. Yep. No, it's so much better to answer questions incorrectly. In fact, I was telling Cole the other day that I love having him in class because he is very eager to answer questions and get them wrong. And that actually helps me as a teacher more than if you answer a question and get it right. So help me out by answering questions wrong. Okay, so here we are now at xenon. We need to make it all the way down to erbium. So now after xenon comes cesium. What's the row number for cesium? Good. And we're going to go through the S block 2 times. So that'll be 6s2. That gets me to lanthanum. But then after lanthanum, right away, we're going to go down into the F block. So this is what you will do. To indicate the electron from lanthanum, you will write 5d1. That's lanthanum's electron. But now we got to dip down into the F and travel through this F. What is the row number of cerium down in the F? It is 4. You keep the D1, yep. All right, so then let's just count how many columns we go through. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So erbium's electron configuration would be xenon, 6s2, 5d1, 4f11. Don't leave out this friend.
Why is it?
Because the F orbital has less energy even than the D.
Oh, so we don't got the F bar.
No. I know that this is confusing, and Dominic, your question was a good one. Why do we need to know this? You don't. But what is good is to train your brain to think in this very this is the pattern, I must follow the pattern, and I can't deviate from the pattern. So it's good to train your brain in that way. I just find it to be professionally distasteful because I hate teaching you stuff that I know full well. I'm going to teach you this now and we'll never do this again for the entire year.
This won't be on the test.
What'd you say?
This won't be on the test.
There will be some on the test, yes. On the first test, but then after that. What did you say? 4F says 11.
How does that look on the first sheet?
Sorry, do you need to go to the eye doctor? Ryan Cole sits in my first row and doesn't wear his glasses, and he squints the entire time in the first row. Ryan. He's just always sitting up there.
That's for you.
Well, I mean, you could choose worse boyfriends. It's fine.
They're technically dating.
All right, so now let's go into. Anybody have any questions about this? If you're still feeling confused, that's okay. Come see me in Jet Block, but don't come see me today. I've got Mrs. Newberry's Jet Block as well. It's going to be a full house in here. All right, so let's switch gears now and talk a little bit about the Lewis dot structures. Have you heard of this before? Lily, Addison, Elliot, did Mr. Dermis teach you about Lewis dot structures a little bit?
This Grace box.
She might have done as well.
Just kidding.
Okay, so it's actually pretty simple. It seems complicated because there's kind of a lot going on, but it's one of those things where if you follow what the rules are, you should be able to solve the problem. So I'm going to teach you how to do this. I'm going to show you about the lab we're doing on Friday because the lab is going to actually help you to understand these because the lab will be a lot of Lewis dot structures. Okay, so I'm going to teach you how to do this for elements first. So we're going to start with the easiest, most basic thing, and then we'll just get more and more complicated. Okay, so a Lewis dot structure really just shows you what's happening in the outermost shell of the electron configuration. But it's like less complicated than the electron configuration actually is. So for the elements, what you're going to do is firstly write the element symbol. And I'm going to choose oxygen as my example. So here I am with an O, and that's my first step. Step 2 is to determine the number of valence electrons. Remember that the valence electrons are the ones in the outermost shell. It's actually super simple to determine valence electrons. Remember when I had you label the periodic tables that you have, and above each of the columns you wrote numbers? Like one was like a plus or a minus, and the other one was a number and then the letter A. Do you remember that?
Yeah.
That's your group number. So the number of valence electrons is equal to your group number. That's it. So oxygen is in which group?
It is 6A.
6A. So how many valence electrons does it have? Yeah, that's it. All right. So we figured out how many valence electrons we have. Now, the third step is to place the electrons around the element. How are we going to do that? 1 electron equals 1 dot. But there's a specific way that you have to do this. You can't just and call it a day. That's not okay. So I'm going to write on the board how you do that, and then I'll explain it. So you're going to put one dot on each of the four sides of the, like, so pretend that this is a box. And you'll start by putting one dot on each of the sides. So that would look like this. 1, 2, 3, 4. Because remember, electrons don't want to be near each other. So we want to show in a picture the way that those electrons are going to try to avoid each other as much as possible. And then, because we've only placed 4 dots here, we need to do something with the other 2. Then, put the remaining dots as far from each other as possible, but also on the sides. So I'm going to say, then put the remaining dots on the opposite sides. So for example, if I put my 5th dot here, the opposite side of that dot would be over here. Does that make sense? My language with what I did. So you really want to try to make it as symmetrical as possible. Sometimes it can't be symmetrical, and that's okay. But we want to try to make it look symmetrical. Okay, so those are the rules for just regular elements. Let's do a couple of examples. Since this is pretty easy, well, let me give you some confidence here by giving you something I think you can handle before I break your heart. Draw a Lewis dot structure for nitrogen. So I've got that started for you. You've already got the element symbol. How many valence electrons should you have? You should have 5 because it's in group 5. All right, now then place your dots. So the first 4 are always going to go like this. And then you have 1 remaining, so I don't know. I usually put it on the side.
Put it wherever you want.
But it doesn't matter. The 5th one does not matter where it goes. So this Lewis dot structure is the same as this. The placement of the electrons is different, but they are both equally accurate. All right, draw a Lewis dot structure for sodium.
You know that?
What? How many dots should it have? Correct. That's it. On this periodic table, they are uppercase, which is another reason why that, like, there are a whole bunch of errors in there. And so when I first started teaching here, I was like, that's it. I'm going to paint over that son of a bitch, and we're going to get rid of it. Because I also thought it was ugly, but now it's kind of growing on me. And I also feel like I don't know if I want to be the one to go through the work of having to do that. Like, it looks pretty nice. Like, somebody took quite a bit of effort. But do not do what they did. So, like, do you see find bromine? It's number 35. Do you see how it's B capital R? That's not acceptable. Or, like, right above it, C capital L. Not acceptable. So you don't do what they're doing on this periodic table, because that's not okay. Gentlemen. All right, let's make it a little bit harder.
Wait, does it matter what side you put the dice on?
No. All right, what happens if you have an ion, though? Come on in. The camera's right in the back. Karen, Mrs. Geeson's here for you. Okay, so there are 2 different kinds of ions. The first kind of ion is called an anion. It's negatively charged. So you're going to do everything the same except when it comes to determining your valence electrons, because you don't have the same situation that you normally would have. Go ahead then. All right, so here's how you determine valence electrons.
What does that say? What does that first one say?
Anion. A-N-I-O-N. sometimes like the writing like makes these weird points, and I don't know how to fix make it to not do that. Okay, so determining valence electrons. You're going to take the group number. Let me do this. And you are going to add whatever number is the charge. Don't worry, we'll do some examples. Okay, so for example, what if you have phosphorus but it's 3 minus? Okay, so we need to figure out the number of dots or valence electrons. What's your group number for phosphorus?
5.
It's 5. And so then what is the charge?
3 minus.
It's 3 minus, but I'm just going to write the charge number. Don't add the sign as well. So 5 plus 3 is 8. Oh, why do we buy it? Who is this? Who's biting?
He's a biter.
Jake's a biter too.
It's still not young.
It was on the ground.
You know, little Joe, when he was a little boy, we used to call him Goat Baby because he would crawl under the kitchen table and eat mail. Mail, yeah, like mail from the post office. You know, like you get like one of those political mailers, he would eat it. Or if it was like a cardboard, something, he would eat it. One time we thought we had mice in the house because the boy's dad had like these like blocks for like doing yoga, and there were all these bite marks in the block. It was like kind of like a foam block, and we thought we had mice, but no, it was a little joke. So we called him Goat Baby. Okay, so do you see I put the 8 dots around the P? Does that make sense? Okay, let's do another one. Bromine is Br minus. So what group is bromine in? 7. And then what's the number of the charge? So 7 plus 1 is also 8. We'll talk about why it's always 8 in a little bit. Now, if you don't include the charge also in your Lewis dot structure, it's wrong. Because regular P doesn't have 8 dots on it. So if you don't have the 3 minus, P with 8 dots is not okay. So make sure you write that charge in there as well. All right, so if that's how it is for the negative ion, the positive ion is the same but in reverse. Guys, a cation is a positively charged ion. So you're going to do the exact opposite. So now your dots or your valence electrons is equal to your group number minus your charge number. You will find that mostly when you have a cation, you will have 0 valence electrons. So for example, sodium is Na+. We just did sodium before. Its group number is 1. What's the number of the charge? 1 as well. So 1 minus 1 is 0. So your Lewis dot structure then, if you don't have any dots to put around it, this is your Lewis dot structure. Lewis dot structure. All right, let's do another one. What about calcium? What group is calcium in? 2A. And what's its charge? 2. So 2 minus 2 is 0. This is your valid Lewis structure. It doesn't make sense though if you don't have the plus. So calcium regular does not have 0 dots. Calcium regular has 2 dots. So notice the difference. If you don't have the charge, it can't be correct. Elliot.
Why do you subtract what is positive and add what is negative?
That's just the way that I think about it. But if it makes more sense to you to always subtract whatever the numerical value is, that's okay. The reason that I do it this way is because to me this is what it logically says. I start with 1 electron, but I've lost 1 electron because that's what a plus charge means. And that's why I have 0. So mathematically it doesn't make sense to do it this way, but chemistry-wise it does make sense. In the same way that I'm adding it here because what does a minus charge mean? It means that I started out with 5 electrons regular, but then I added 3 more. So as I've been teaching this to you, I thought to myself, yes, it would have been so much easier to just do everything group number minus the actual numerical value of the charge, including the minus or plus sign, but that's not true chemically. And I want you to think of as chemists and not mathematicians. Dominic?
How do you know the charge?
You'll be given it. You'll be given it. So like looking at your homework then, there are a couple of these kinds of problems right at the end. Oh, I got work I gotta hand back to you guys. So like B on number 14 of your homework. GA3 plus, I tell you what the charge is. So what, how many valence electrons does this element have? Well, what group is gallium in?
It is in.
It's in 3, right? So 3 minus 3 is 0. This is what goes in the box. What? Say that again, Carter?
What we given the charge, you said?
Yep, yep.
So what? Like, how did you find the charge?
I'm looking right at my homework.
Oh, okay.
And I'm seeing that I just wrote down exactly what the homework told me. And so if I were to answer this in the nice box that I made for you, write this exactly what I wrote here. Because if you don't have the 3 plus, it can't be correct. Does that make sense? Hunter?
So just use now.
Yes.
Negative.
Yes.
What do we do if there's 2 elements?
If there's 2 elements, you don't know how to do that yet. Let me explain that. Elliot?
The ones with the 2 elements?
I'm going to explain that right now. All right, so for compounds, in other words, you have more than one capital letter, more than one element. This is what we do. So the first thing that we have to do is figure out the total number of valence electrons for all the elements that we have. All right, so let me give you an example. Let's do CHO as an example. All right, so in order to calculate the total number of valence electrons, we need to look at each element individually. So how many does carbon have? Let's do CH2O. My bad. How many valence electrons does carbon have? 4. Now, there are 2 hydrogens. That's what this means here in the compound. So if there are 2 hydrogens, we have to multiply whatever hydrogen's group number is by 2. So what's hydrogen's group number? And then how many valence electrons does oxygen have? 6. So what's this grand total?
12, 2, 4.
Yep.
What?
Yeah, 4 plus 2 is 6, plus 6 is 12. All right, so we did that. That's step 1. Now is the tricky part. So we have to try to like organize our atoms kind of like a puzzle. And it's tricky for me because I am like spatially illiterate. And so my best suggestion for you is to like try to make your compound as symmetrical as possible. So I'm going to write on here that the second step is to arrange your atoms as symmetrically as possible. I hope symmetrically is a word. with as much symmetry. I don't know, it just seems like a waste of time. All right, so I've got a C, an O, and 2 H's. Whew. I mean, that's the only thing I can think of. You will see and learn how to do this by doing the lab on Friday, because you will learn what can go together and what can't. For example, on Friday we'll be making models really similarly to the ones that are on the walls. So like in the back, that's ethanol. And so you'll see that hydrogen is the yellow ball and it only has one hole. So that means that it can't like be part of a chain. It can only be at the end of a thing because it can't connect to something other than its one thing. Okay, so once we've got the atoms arranged here, the third step is to add the dots for elements. So hydrogen has 1, so I'm going to put the hydrogens there. Carbon has 4. Oxygen has 6. Now the next step in the process is to connect dots between atoms. Every one of the lines represents one bond. So here are 2 dots between atoms, 2 dots between atoms, 2 dots between atoms. Here are 2 dots, but they are not between atoms, so I'm not going to put a line here. That does not make sense. Don't do that. The instructions say to connect the dots between atoms. Now step 5 is the fun bit, because this is where you have to use your brain. All right, I'm going to write the last step here on the board. Well, it's not really the last step, there's another one. The rule is check to be sure all elements are, I'm going to call it atoms instead. Check to be sure that all the atoms have what's called a full octet. There is an exception to this. Hydrogen's full octet equals 2 electrons. For everyone else, a full octet means that they need to have 8 electrons. Okay, this is going to be a little bit tricky, and I promise you that doing the lab on Friday will make this easier. I'm going to help you with the homework problems, though, for now, so that you have those answered. All right, so now I'm going to use a different color here for my hydrogens to make sure that their octet is full. I can circle every electron that is next to hydrogen, including the ones that it shares. Because if it asks nicely, hydrogen can have this electron from carbon. Are these 2 hydrogens having full octets? They are, because a full octet for hydrogen is only 2 electrons. All right, now let's look at carbon. Again, I can circle every electron that carbon is next to, including the ones that it was sharing with hydrogen. So these electrons are going to be circled twice. How many electrons are in the green circle? You're right. There are 7. Is that 8? No, so not a full octet. All right, so now I'm going to look at oxygen. I can circle all of the electrons around oxygen, including the one that was also circled in the green one. How many electrons in the red circle? We have two things that do not have a full octet, but I can't use any more electrons than what I calculated here. I can't just go in and add dots because I don't have any to add. So what do? If atoms don't have a full octet, they must share more electrons with someone else. If atoms do not have a full octet, they have to share electrons with someone else. So conveniently, I have right next to each other two atoms that don't have full octets. So what I want to do is let this electron here, this dot, come up over here. And I'm going to take this dot here from my oxygen and move it over here, so that then they can be in those circles being shared even more. What will that look like? Let me show you. This is what we had before. And now the new bond I've drawn in red. So now let's check to see if everyone's octet is full. Now oxygen has two. Remember, every line is 2 electrons. I didn't write that down. One line equals 2 electrons. So 2, 4, 6, 8. 8 electrons in the red circle. How many electrons in the green circle now? And so everyone has a full octet. This is a valid Lewis structure. So if you were to write this in your answer, what would you write? Exactly this. Including those dots on that oxygen. This would be your answer. I know that it's true because I've used 12 total electrons. 2, 4, 6, 8, 10, 12. And everyone has a full octet. All right, let's look at number A on your homework. C2H4. All right, let's go through the steps. The first thing is to calculate the number of valence electrons. So how many valence electrons does carbon have? Or what group is it in? It's in 4. So 2 times 4 is 8. There are 4 H's. H is in what group? 1. So it has 4. Again, we have 12 electrons to use. Okay, so because I know about chemistry, this is what I'm going to tell you to do. We want this to be as symmetrical as possible. So we're going to put those 2 carbons in the middle. And then maybe this? Yes. How'd it go?
Very good.
Okay, good. Does she have any more on those food trucks?
Yeah.
Okay.
She's gonna see that she's pretty much gonna do most of that work.
Okay, yeah.
Because she's done a lot of that.
Yeah, and she's got a lot of contacts with them, yeah.
Yeah.
I gave her my blessing to do that because I wouldn't even know where to start. Awesome, awesome sauce. All right, second step is to place the dots for each element. So hydrogen, I'm gonna do those first. Hydrogen has 1. And now here, before, remember I said it didn't matter where you put the dots. You want to put the dots closest to the next thing that it's like next to, because they're gonna share. And then carbon has 4, so 1, 2, 3, 4. Now I'm going to connect the dots between atoms. So 1 here, 1 here, 1 here, 1 here, and 1 here. And now I'm going to check if I have a full octet. So if you're working on this on your homework paper, don't do this. Let me do it for you. I'm going to circle all the hydrogens and I'm going to look at them first. Are any of these hydrogens not having a full octet? No, so they're good. No worries. The carbons, though, don't look full. So how many electrons in the first green circle?
What'd you say?
How many electrons in this green circle?
1, 2, 6.
7. Because there's this guy up here.
Oh.
All right, let's draw an orange circle for this carbon. How many electrons in this circle?
7.
Also 7. So we have to do what we did last time. These 2 electrons have to come down so that they can also be shared. So then, what would that look like? No, you don't have to. I had to because I had that mess over there. So I would just erase my 2 dots there and then draw them in the middle.
How do we have to write the last section?
What'd you say?
Wait, okay. Is that the answer?
This is the This is your answer.
Why don't you have to write the 2 dots above this?
Because I brought them down. They're now a part of this bond.
Okay.
They're this line. They became this line here. That's a good question for her. I did a bad job of explaining that.
Well, I had a distraction.
No, it was actually me.
What do you think you are? Yeah.
I think this might be a personal low for me. I had 1 hour of sleep last night.
Why?
I was asleep for 1 hour and then I had such a terrible dream. I woke up and had a panic attack. And I haven't had a panic attack in like 3 years. And I just could never get back to sleep.
Whatever Darwin has a panic attack, he watches Jeffy.
What'd you say?
He watches Jeffy get panic attacks.
Really? Really? Okay. You know, now that they took off like the OG videos because, you know, they got sued by Mario Brothers, they're like just not as funny anymore. Yeah, that's what Joe was saying. Those were the funniest ones with Mario and the princess. Yeah. Oh. Yeah. That's what you got to do. That you got to find the pirated ones. All right. Okay. Enough talk about Jeffy. Let's do number D. All right. Your first step is to find your valence electrons. So you've got 2 H's. 2 times 1 is 2. You've got 2 O's. 2 times 6 is.
Wow. Oh, why is there 6?
It's O is in group 6.
Oh, okay.
Okay, so we've got 14 electrons we can use.
Yep.
All right, let's arrange our things. We want it to be symmetrical, so I think that's symmetrical. And now let's place our dots. 1, 2, 3, 4, 5, 6. Well, okay, I was being stupid. I'm sorry. Don't listen to me. Now connect your dots, but only connect dots between atoms. So the dots on the tops and bottoms of the O, do not connect them. All right, not on your paper. Let me do it for you. Eight electrons, yes or no?
Yes.
Okay, good. 8 electrons, yes or no?
Yeah.
All right, let's do the H's. Do they need to have 8 electrons? No. How many do they need to have? 2. Are they full? This is okay, and then check to make sure you've got the 14 electrons. 2, 4, 6, 8, 10, 12, 14, valid Lewis dot structure. So how should it look on your paper? Probably exactly the way you already have it. That's it. Does that make sense? Maybe a little? I think you can do E on your own. But I'm going to give you a hint. This is a good place to start. This isn't all there is, but this is a good place to start. Yes?
Can you go back to that writing?
Oh, sure. I'm so sorry. Yes.
See, this one's that one's.
All right. I'm going to stop this video and I will come back on and explain labs in a bit.